Hi, second year students. It's math with AUB. The remaining portion of the exercise 3.3 from 7 to 12. The remaining I have to compile, as well as I am compelled to revise these two questions as they have good concept for you. When to suppose 10, when to suppose sine or sec, and what do you mean by completing square integration? Question number one, without wasting time, the good one. I have several times told you function derivative works wonder for you. Function derivative works wonder for you. It is not the simple integration because we cannot multiply integral dx. I have written dx two times. Sorry. Integral and dx we cannot multiply throughout the term because something is in numerator, denominator. Second strategy, function derivative. If I suppose this one as f of x, that is, take only base without overall power. Take only base, f dash of x. We have 4 times 2x plus 0, that's equal to 8x, f dash of x. So we need 8 here, 8 here, divide and multiply by it, divide and multiply by it. It will become something like that, 1 over 8, 8x dx overall 4x square plus 1 whole cube. Or direct, one can inspect and evaluate. In differentiation of 4x square is 8x, divide and multiply by 8 in order to compensate the deficiency. The same situation of function and derivative, function derivative, function derivative. Function is in the numerator, having not power 1, we are entitled to get into numerator by minus 3 and so on. Let's see, that's the strategy. Function derivative overall power is not 1, we are entitled to do so like this, 4x square plus 1 raised negative 3, 8x dx. Function derivative, function derivative, function derivative. Add 1 into the power of function, it will become 4x square plus 1. Minus 3 plus 1, it will become negative 2, dividing with the same plus c. They are in single denominator, overall 8, overall 2. It will become minus 1 over 16. Turn this exponent to positive, we can write as 1 over 4x square plus 1 overall square plus c. This is our answer. This is our answer. Function derivative works wonder for you. Function derivative works wonder for you. Or one can, by substituting, it's equal to or 1 over 8 divide and multiply f dash of x dx. There is overall f of x raised 3. Switch this one into numerator like as this and so on. Okay, or by simply y is equal to this one and that. Function and derivative works wonder for you. Function derivative works wonder for you. Differentiation of 4x square is 8x. X is present, deficiency of it, we can compensate by dividing and multiplying. By dividing and multiplying. Overall power is not 1. We shifted the function into the numerator. Here, there is a case, add 1 into the power of function only. Only in the power of function. Minus 3 plus 1 minus 2 divided with the same, and the rest is simplification. Function derivative works wonder for you in integration. Moving towards next question after 7, 8. That is, we have x4 root 3x 5 minus 5 dx. Look at this. Differentiation of 3x power 5, it will become 15x4, 15 times x4. x4 is there, only deficiency of 15 we can compensate. Write function first, 3x raised to 5 minus 5. Under root means 1 over 2. Here is x4 dx. Simply substitute. Suppose f of x or y is equal to our function. Suppose y is equal to 3x raised to 5 minus 5. Take only base without overall power. Take only base. Differentiation with respect to x, dy over dx. 3x5 means 5x4 minus 0. So we have dy is equal to 15 times x4 dx. This is another style, or we can directly divide and multiply by 15, or find the value of x4 dx, shift 15 here. The differential of dy dividing by 15 is equal to x4 dx. These two values to be replaced in the original integral, we have something like this. It's equal to y overall raised 1 over 2. Instead of x4 dx, we have dy over 15. Dy over 15. 15 is a constant in the denominator. We can write 1 over 15. Add 1 into the power of function. It's simple integration now. Adding 1 into 1 upon 2, it will give us 3 over 2. That is 3 over 2. They are in single denominator, 15 and 3. They are multiplied. 2 will be in numerator, constant c. We have 2 over 3 times 15 is 45. Reput the value of y. Reput the value of y. It is 3x power 5 minus 5. 3x power 5 minus 5 plus c. That's the power. Let me write clearly. 3 over 2 plus c. 2 over 45. 3x raised 5 minus 5 over 15. Function derivative works wonder for you. There is root 1 over 2 under root. We cannot multiply integral and dx throughout with each term. Then second idea must be substitution. Look at there is x5. A differentiation is 5x4. x4 is present there. x4 is present there. The rest is the deficiency of constant or symbol we can compensate. Suppose, assume y is equal to 3x power 5 minus 5. Differentiating with respect to x, it will become 3. x5 means 5x times 4. Differentiation of a constant is 0. 15x4. Manage the value of x4 dx that we have. Shift 15 here. We put the value. It is y raised 1 over 2. Its dy is 15. 15 outside, y raised 1 over 2 dy. Add 1 to the power. 1 over 2 plus 1, it will become 3 over 2. Reput the value of y and so on. Function derivative works wonder for you. Wonder for you. Question number 9. Question number 9. That is 2x plus b overall times dx divided by ax square plus bx plus c. Function derivative. Differentiation of ax square is 2 times ax. That's present here. Differentiation of bx is only b. Differentiation of constant is 0. Don't forget, function has overall power 1. I'm writing in order to emphasize the underlying idea concept. If function is in the denominator having overall power 1, it is the case of Allen. Let me explain to you again. Differentiation is in the numerator. Function is in the denominator having overall power 1. Derivative function. Function is in numerator. Differentiation is in denominator. Function having overall power 1. It is the case of Allen. Whatever is the function present in the denominator, let's see its integration. This idea comes from what is the differentiation of Allen x. Everybody's formula 1 over x. Differentiation of x is 1. So integration of 1 over x must be Ln x. That's the idea. When function is in the numerator, function is in the denominator having overall power 1. When function is in the denominator having overall power 1, it is a case of Ln. So does the situation is here. Suppose y is equal to ax square plus bx plus c. Suppose differentiating with respect to x, dy over dx, ax square means 2x plus b, differentiation of x is 1, differentiation of a constant is 0. Shift differential dx here. Differential of y is equal to ax plus b times dx. That's number 2. That's number 1. Substitute both values here. 2x plus b dx can be substituted by dy and it's by y. Having overall power 1, let me write again in order to emphasize. It's 1 over y dy. It's the situation of ln whatever is the function in denominator. We put the value of ln. Y means ax square plus bx plus c ax square plus bx plus c. Here already c, so change your integration constant. It might be c1, another constant, c1. And ln is defined for positive values greater than 1. Positive values greater than 1, that's why we have written this quantity is in the modulus. That's our answer here. Question number 10. Function derivative. 11. Function derivative. Function derivative works wonderfully. Question number 10. Question number 10, we have dx over 1 minus 3x raised square. There is no need to open a square. What is differentiation of negative 3x? That's minus 3. Negative 3. It's a constant, we can compensate. Overall function is not 1. It can be shifted to numerator. So we have something like this. 1 minus 3x raised minus 2 dx. Suppose it's equal to what? Like a baby, we are taking supposition in order to give you clear view. Whenever you have view of function derivative, then we do it direct. Don't take overall power while substituting. dy over dx, differentiation of 1 is 0, 3 times differentiation of x is 1. Solve for differential y, it will become minus 3 dx. Look here, it is y, we need value of this one. So dx is dy divided by negative 3 is equal to dx. This is second value, this is first value. Both substitute in original integral. We have y raised minus 2 times the dy over minus 3. This is y raised minus 2, dx means dy over minus 3. Minus 1 over 3 is the constant to be right outside. We have y minus 2 dy. Add 1 into the power. It will become minus 1 dividing with the same. Plus c, minus plus 1 over 3. Make the exponent positive, write in denominator. What is value of y? Re-put here. It will become 1 over 3. 1 over y means 1 minus 3x plus c. It's our answer. I am taking pain. I am taking troubles because of you in order to give you good view. Understanding phase. It is understanding phase. Initial phase. Then it's simple one otherwise. Here, deficiency of minus 3. Divide and multiply by minus 3. Add 1 to the power of function. Like this. Whenever we have grip on this, we have something like this. Differentiation of this one is minus 3. Dividing and multiplying by minus 3. We have 1 minus 3x raised minus 2 minus 3 dx. How we come to know that there is differentiation of negative 3? Differentiate this one. Differentiation of 1 is 0, minus 3 is minus 3. Differentiation of minus 3, divide and multiply. Function derivative, and add 1 into the power of function only. 1 minus 3x, it will become minus 1, dividing with the same. Negative, positive 1 over 3. Turn this exponent to be positive, it will become 1 minus 3x raised to 1, right or not. It's our answer direct. We are taking supposition, putting the values in order to give you view, understanding, letting your foundation strong enough to bear the load and negotiate the upcoming questions in a good fashion. Because after this chapter, we have a chapter of differential equation. Differential equation is also the mystery of integration. Question number 11, we have z cube divided by 1 plus z4. Look at this. Differentiation of z4 is 4z cube. There is only deficiency of 4. Divide and multiply. There is 1 plus z overall 4. Having overall power 1, situation of ln. Function derivative. Function is in the denominator, having overall power 1. It's the case of ln 1 over 4. Ln whatever the function is in denominator. Let's see, it's our answer. We are doing a bit direct in order to give you good view. That is simple substitution. A step or so question. Otherwise, we have to linger on, take trouble to give you concept. Suppose y is equal to 1 plus z raised 4. differentiating with respect to z, dy over dz. 1 is 0, z4 means 4z cube. Shift dz here, dy is equal to 4z cube dz. We are interested in the value of z cube and dz. Shift 4 here. Dy over 4 is equal to z cube dz. That's number 2. That's number 1. Substitute in the original integral we have. Instead of z cube dz, we have dy over 4 dividing by y. Dividing by y over all power 1. This is 1 upon 4 is constant right outside. 1 over 4 dy over y. Here function derivative having overall power 1. The situation of ln whatever is present with is in the denominator. We put the value of y, that is 1 plus z power 4. That is our 1 over 4 ln 1 plus z power 4 plus c is our answer. Function derivative with the deficiency of a constant 4 divide and multiply overall power 1 I have written for you. Overall power 1 I have written for you. ONE. Function derivative, add 1 into the power of function after compensating the deficiency of 4 dividing and multiplying. That we have just earlier did direct. Okay, question number 12. We are done with exercise 3.3, and that is 12 cot inverse x overall 1 plus x square. Negotiate the situation, negotiate the term in a good fashion. Cot inverse x, I can write this one as 1 plus x square. Cot inverse times 1 over 1 plus x square. Differentiation of cot inverse x is negative 1 over 1 plus x square. Here is deficiency of only minus. Here is deficiency of only a minus. Compensating the deficiency of minus, we have minus 1 plus x square dx. That's our function. Function derivative. Add 1 into the power of the function minus cot inverse x. Overall power is 1. 1 plus 1. It's 2. Dividing with the same plus c. It's our answer. Differentiation of cot inverse x is negative 1 over 1 plus x square. Reading the situation, evaluating the deficiency, that's negative. Multiply 2 times. Compensating the deficiency of negative. It's our function derivative. Overall power is 1. Cot inverse is function. Don't add 1 into it. It's function. Overall power 1. Add 1 into this. 1 plus 1, 2. Dividing with the same. It's our answer. Cot inverse x overall 1 plus x square. Its integration is given by negative times cot square. Cot inverse x overall square divided by 2. Dividing by 2, R1 can take the trouble. Suppose this is function and you find the value of this one. It will become y, it will become negative dy, and so on. You can attempt. Okay, let me solve this one for you as well. This one can be written as cot inverse x times 1 over 1 plus x square dx. Suppose y is equal to cot inverse x dy over dx. Differentiation of cot inverse x is negative 1 over 1 plus x square. Shift dx here. Solve for differential. It will become 1 plus x square dx. We are interested in the value of positive 1 over 1 plus x square dx. Multiplying by minus, we have minus dy is equal to 1 plus x square dx. That's our number 2. That's our number 1. Substitute here. It will become y and it will become our negative dy. Right minus outside. It will become y dy. Add 1 to the power. Y square over 2. We put the value of y, that is cot inverse x, negative 1 over 2, cot inverse x overall 2 plus c is the same answer that we have done earlier. So we have done with 3.3. Okay, let me give you a good idea about question number 5 and 6. I have selected for you to give you good view how to make something complete square and when to suppose sine or cos. 5, question number 5. Let me utilize the space properly. Dy over y square plus 8y plus 20. 8y plus 20. Look at this. It is not a function derivative situation. It can be converted into any case by making it perfect square. Making it perfect square. We can do so by taking a tiny effort or concept. First square, it will be twice. First into second. There is 8y. So first one is y. There is what? 2 times y times what is equal to 8. 2 times y times what is equal to it. It must be 4. It must be 4. It must be 4. Or take only these 2y, 8y divided by 2y, you will get the 4. There is 8y, we have done so. That's our 2y. Dividing with that, we come to know that 4 is the other quantity. 4 is the other quantity. Okay. Y square plus 2y. There is 16. There's 20. There's 20. Okay. We can write 4 square add as well as subtract. Keep these 20 intact. As 20 intact. Or you can split 20 as 16 plus 4. 16 plus 4. 16 to be taken for perfect square. 4 outside. Whatever source you do that. We have dy over, now it's perfect square formula for y plus 4 overall square. Let me write a square to be, yes, y plus 4 whole square. Take the first one and the third one, symbol of the middle one. What remains here? Minus 16 plus 4. Let me clarify the situation. This square belongs to 4 only. This square power belongs to 4 only, not negative. Minus 16 plus 20, it will become something dy over y plus 4 whole square plus 4. This is situation of a square plus x square. X square plus a square. X square plus a square. When to suppose 10 dy, it will become y plus 4. Instead of 4, I can manage 2 square. Now this is our situation. This is our x. This is our x square. This is our a square. In that case, we have to suppose x is equal to a tan theta. We have to suppose x is equal to a tan theta. Comparing with the prevailing situation, instead of x, we have to take y plus 4. Instead of a, we have to take 2 tan same. Differentiating with respect to theta, dy over theta, differentiation of 4 is 0. Differentiation of tan is sec square. Shift d theta over there. We have dy is equal to sec square theta d theta. That's number 2. That's number 1. Re-put here. Our question will become something. Instead of dy, we can write 2 sec square theta d theta. Overall, instead of y plus 4, we can write 2 tan. There is square, I can write 2 square, tan square. This 2 square remains same. This 2 square remains same. This 2 square remains same. Instead of y plus 4, I have written 2 square tan square because y plus 4 is a square. There is 2 square. Taking 2 square common from the denominator, we have something like this 2 sec square theta d theta, 2 square common. What remains? Tan square plus 1. Tan square plus 1 is equal to sec square. Then they are neutralized. What remain here? 1 over 2. Let me write for you. Sec square theta dividing by tan square plus 1 is equal to sec square theta d theta. Cancelled out. What remains? 1 over 2 1 d theta. Means 1 over 2 integration of 1 with respect to theta is theta. Re-put the value of theta from here. Re-put the value of theta from here. Let me, I have managed the show. Let me erase a step also to make a step, make a space for you. This one. We have assumed that y plus 4 is equal to tan theta. We are interested in theta. Shift 2 here. It will become y plus 4 divided by 2 is equal to tan. Taking tan inverse both sides, we have tan inverse of y plus 4 overall 2 is tan inverse times tan theta. They are neutralized. So theta is equal to, this is value of theta. Theta is equal to tan inverse of y plus 4 overall 2. So that's our final answer. 1 over 2. Theta means tan inverse of or arc tan tan inverse of y plus 4 dividing by 2 plus c is our final answer in that case. In that case. First make perfect square and then you come to know it is situation of I have erased the board, that is x square plus a square. In that case we have to take magic substitution, x is equal to a tan theta. X is equal to a tan theta. Question number 6 is same but it is in the square root. Let's see how to manage this. The final 2 to 3 minutes to this question. First make perfect square, then take magic substitution. Let's see. Integration dx dividing by 20 minus x square minus 4x. Look, function derivative is not a situation here. So try to make a perfect square term in square root. There is 20, leave it. Taking minus common, we have x square plus 4x. If I would have taken x common, then there is no more perfect square type strategy. Alright, in perfect square, right, leave 20 same, minus square of first, there might be twice first into second, there is x. We need 4 here. What is that? 2x, here is 4x. 4x divided by 2 is, the other term is 2. One can easily verify. 4. 4 can be 2 times x times 2. So the other term is 2. There must be 2 square. Add as well as subtract. Add as well as subtract. Here is the perfect square. It's perfect square. Take first one and third one without square. Take the symbol of the middle one. First and third without square. First and third without square. Symbol of the middle one. So we have something like that. Dx over root 20 minus, it will become x plus 2 overall square. Square belongs to only 2, it will become minus 2. Open up, multiply minus, then we come to know that what we have to suppose, either sign or sec. 20 minus x plus 2 whole square minus plus minus plus. Now there is 20, there is 4, it will become 24. Dx over 24 minus x plus 2 whole square. It is not a perfect square quantity. Try to fit in square situation. 24 can be written as 2 times root 6 square. 2 times root 6 square minus x plus 2 whole square. Now that is the situation, a square minus x square. In that case, we have to suppose x is equal to a sin theta or x is equal to a cos theta. X is equal to a sin theta or x is equal to a cos theta. Mostly, generally, sin has been taken. So let me take sin for you. Compare the situation here. A is equal to 2 under root 6 and x is equal to x plus 2. Then x plus 2 is equal to 2 times root 6 sin theta. Same strategy, differentiate with respect to theta, dx over d theta. Differentiation of 2 is 0. 2 times root 6 differentiation of sine is only cos. Solve for differential x. Shift d theta over there. We have dx is equal to 2 times root 6 cos theta d theta. That's our number 2. That's our number 1. Fit these values here. Dx means 2 times root 6 cos theta, and here instead of x plus 2, write 2 times 6 sin theta. 2 times 6 sin theta. So we have something like this. Let me erase this in order to make this peaceful. Okay, put both these values here. It will become, instead of dx, let me write 2 times root 6 cos theta d theta overall root 2 root 6 square minus, instead of x plus 2, I can write 2 times root 6 times sin theta. 2 times root 6 times sin theta. Okay, give me square on separate. Taking 2 times root 6 square common, what we are left with, taking 2 times root 6 square common from the square root. What remains here? Nothing. 1 minus sine square. 1 minus sine square is equal to cos square. 1 minus sine square, it is equal to cos square. So we have, what is the root of 2 times root 6 square? Square and root cancel, it comes outside. 2 times root 6. So we have 2 times root 6 times cos theta d theta. It is 2 times root 6 under root 1 minus sine square is equal to cos square. Cancelled out. Square and root cancel. We have cos theta divided by cos theta d theta neutralized. We have only 1 d theta. 1 d theta means theta plus c, theta plus c. Manage the value of theta from here. Shift 2 times root 6 in denominator, taking sine inverse both sides. We have sine inverse of x plus 2 dividing by 2 root 6 plus c. That's our answer in that case. That's our answer in that case. From how I manage the value of theta from here, let's see very clearly. Shift 2 times root 6 here. X plus 2 divided by 2 root 6 is equal to sine theta. We are interested in theta, taking arc sine or sine inverse both sides. Arc sine or sine inverse both sides. We have sine inverse x plus 2 divided by 2 times root 6. It's sine inverse times sine theta. Neutralized. What remains? Theta is equal to sine inverse of x plus 2 divided by 2 plus 6 plus c. Plus c, I have written over there. That's the value of theta. That's the value of theta. That is my tiny effort for you to complete exercise 3.3. Next 3 upon 4. Then upcoming chapter based on differential equation. By the way, I have bought this book. It is available now. Where is the book? Where is the book? I have just bought. Where I have left? No idea. Okay, I will show you the book tomorrow. By the way, it is available in the vicinity like Sakkar on 27th July. I have bought this book. I will show you tomorrow. That's all by itself. Next. किताब